Okay, let's get some general forms of a line. Now here we go. Parametric equations of a line. So these are just general things where x could be x equals 2 plus 3t. Y could be like 4 minus 7t. All right, where x naught is 2, a is 3, y naught is 4, b is negative 7, right? So if you have both of these parametric equations are what we consider lines, right? If you were to say this is the t, this is the x, this would have a slope of 3, right? That's a line. Same thing here with y. We could say this is the t-axis. We could say that's the y-axis. We have a slope of negative 7. We have a y-intercept of 4, so it would be something sloping down. All right, so if your parametric equations start as both x and y being lines, if t was your independent variable, when you parameterize, we're still going to get a line. It's just going to be a different type of line. So let's go get a general equation for this. So let's go back to what we've been doing, and I think I'm just going to solve for t on the left-hand side and then plug it in and just see what occurs. So step 1, let's subtract out x naught. All right, so we're going to get x minus x naught is equal to a times t. Well, let's divide out a, and we get that t is equal to x minus x naught all over a. So we will take this and plug it in for t. And let's just see what happens. You know, I mean, something good might pop out of this. We might get a general formula or something. I don't know. So we get y is equal to y naught plus b times our value of t, which is x minus x naught all over a. And something kind of cool is going to pop out of this. Well, if you're a math nerd, something cool is going to pop out of this. Well, let's kick the y naught over to the other side. I just realized that when you say y naught, that could be taken in a different way. Wow. Wow. So we got that out of the way, but now, do you mind, can I take this a and just move it right here? So we end up with b over that a, and then we're left with x minus x naught. Do you recognize that? Do you recognize this? Y minus y1 is equal to m times x minus x1. That's called the point slope form of a line, which it tells you the point x1 comma y1 and the slope. Or we could say that's f prime of your x1, right? We've been messing with this stuff. We've been seeing this for a couple of classes now. So what turned out is we now have a general form of a line. So you wouldn't have to do any work. You could just look at it and be like, hey, it's the slope of the y divided by the slope of the x. B over a. B over a. We get the slope of the line. And that might be a lot. And you're like, I'm not quite getting it. That's fine. That's fine. So here's the summary. What we just showed. For any values of t from negative infinity on up to infinity, because we can plug in any value of t that we want to. They're lines. Yeah. There it is. We just found out. Really, the whole game was just to figure out the new slope of the line. And that we're going to have a point that goes through our x naught, y naught. Let's see it in action. A lot of babbling. So here's an example. So we're going to consider, for part A, we're going to consider the parametric equations x equals negative 2 plus 3t, y equals 4 minus 6t for any value of t which describes a line. Find the slope-intercept form of the line. So that means back here where I showed the line, where I got rid of it, this is point slope. It's actually asking us to take it all the way to y equals mx plus b. So let's not do extra work. Let's not plug all this stuff in. We have x is equal to negative 2 plus 3t. The slope of just that parametric, if we were to make t our independent variable and x our dependent variable, and then we can have y is equal to 4 minus 6t for any value of t. Okay? Just any value. All right. We want to find the slope-intercept form. So we already know the slope. The slope is our b, that's our b, over our a. So the slope of this line is going to be equal to -6 over +3. The slope of our line is -2. Cool, let's just keep that for a second. -2, let's make sure. We got slope is equal to -2. Now we look back up and we're like, well, wait a second. How do we find where it's going to, the points? It's going to be x naught, y naught. Well, our x naught is right here. That's our x naught. It's where it would start at t equals 0. Why I keep saying x sub 0 and why that is, if you plug in t equals 0, wouldn't you just be left with -2? Now we move over to our other, and we can see, well, there's your, what we call our y naught. Because if you were to plug in t equals 0, that's what would have been left over. So we have a point. And all you need is a point in the slope, and you can use point slope, and then just do a small bit of algebra to put it into slope-intercept form. Okay, so we're going to say that our points are -2 from right there, comma 4. Now we put it into y equals, well, let's write it this way, y naught. So that times x minus x naught, our point slope. And then once we go from there, we're just going to clean it up and everything's going to be solid. So we get y minus our y naught, it's 4. Our slope is -2. Our x is just x. And then we get -2 for +2. Now that's point slope form on any exam or anything you do with this teacher. I'm cool, leave it there. That tells a much better story than y equals mx plus b. Big fan of that. But we're going to follow the rules, and you got to do online homework. So that means if it says to put in the slope intercept, get rid of all your dang parentheses and solve for y. So let's add over our 4. And it turns out, oh, wow, I guess this was a much better line for us to mess with. Y equals -2x? Shoot. That's not bad at all. Well, we got ourselves a value of y in terms of x. Let's go. So that thing goes through the origin. I mean, think about the things we can tell from this. Slope is -2, and it goes through 0, 0. That's not bad. That's not bad. Okay, let's do part B. Now we're going to do some backwards thinking. Now we're going to think a little bit backwards. So reading B, we're seeing that it gives us something. Now we're using something completely different. That's why I'm erasing everything. Find 2 pairs of parametric equations. So we want to find these now, given some information. So find 2 pairs of parametric equations for the line with a slope of 1/3. Slope is 1/3. Wait a second. Fraction. And it goes through the point 2, 1. So x naught, y naught is equal to 2, 1. But let me ask you, isn't this equal to b over a? Right here. So it tells us our b is 1. It tells us our a is 3. Our x naught is equal to 2. And our y naught is equal to 1. But these are going to go this way. B goes with y. All right, let's go back up to this and see our general form and see that b goes with our y. Huh? There it is. Oops, oops, oops. B goes with y. All right. So I guess let's just set them up. We can say x is equal to our x naught, right? So we have it this way, plus at. Then we're going to have y is equal to y naught plus bt. Just place things where they go. You got yourself a solution. So x naught is 2 plus our A, which is 3. 3t. There we go. We got our x value. Now let's do it for y. Our y naught is 1. Our b is 1. So we have y is equal to 1 plus t. Cool. So as long as we know the slope and the point, we can set up parametric equations. Cool. But I think there might be more than one answer. Do you see what I mean? Do you see how there could be a different answer to this? That this is describing a parametric equation. Or two pairs of parametric equations. Did you know that 1/3 is the same thing as 2/6? But we already had it reduced, so let's not talk about that anymore, okay? All right, now let's do our last one, where it says find parametric equations for the line segment starting at 4, 7 and ending at 2, -3. All right, well, that's not so bad. It's not. We're doing basic algebra right now. So if you have a point at 4, 7, sorry for the long video, but just want to get this done, and then 2, -3. Can you find the slope of that line and then use one of the points? That's the game. So find the slope. The slope, go back. 7 minus -3. We're just looking at this. Just find the gosh darn slope of a line. I hear students all the time saying, man, I wish I could go back to algebra. Here's your opportunity. So we get 10 over 2, so our slope is 5. So we know that we have a slope is equal to 5 over 1. Therefore, our b is 5. Our a is 1. And we could call this x naught, y naught. We just put it all together. Wait, no, we're going the other way. We're not trying to create anything. Oh, we just have to set it up. So we can say x is equal to our a, 1, plus, nope, I have that backwards. Gosh dang it. That's our slope. Come on, man. That's our x naught. We're supposed to say, right, doesn't it go x naught plus at? So x is equal to our x naught. So I chose 4 plus our at. So that's 1t. So we have x is equal to 4 plus t. And now we do the same thing with our y and say y is equal to, where is it? 7. That's what it is. And then we're going to say plus 5t. There's some parametric equations for the line segment. Ending there. Neat. Now, what would happen? I actually had to choose this one. I couldn't choose, I'm realizing now, I couldn't choose this one. The one that's ending at, instead of the one that's starting at. This line is going this direction. It said it started at 4, 7. So that would mean if it starts there, that's where t equals 0. You actually could not use this point because that would be the ending. We wouldn't know x naught. That means where t equals 0. AKA like y-intercepts and such. Hopefully that made sense. That was a lot of information, but we're trying to get everybody ready. This is supposed to be covered in trigonometry, pre-calculus, but a lot of us do not get to it. I know I'm guilty of it as well. But now we're about to get into the calculus. Trying to make sure that we know what the heck is going on. And now we can start to get into doing some calculus. All right, I'll see you in the next video. This was way too long. I'll try and keep the next one under 10 minutes.